Hey everybody, welcome back to the channel. So today we're going to be going over the weekly overview for week 6. So without further ado, let's jump right into it. But as always, before we actually get into the meat of the content, we have to go over the agenda. As you can see, the agenda is fairly short this week. Not really covering a whole lot of topics, but more so focusing on the fruit of the topics. So, in today we're going to be talking about agents. What are they, and what are their case purposes, as well as examples. And then we're going to talk a little bit about Google's Vertex AI a bit. What is it and stuff like that. So let's talk about agents. Okay, so what is an agent? An agent is an autonomous system that, let's say, perceives their environment and takes actions to achieve specific goals. So, the key characteristics of a agent sort of vary. It usually processes information to make decisions, right? It acts through effectors or actuators, and then it normally perceives the environment through sensors. So think like, for example, self-driving cars. Self-driving cars obviously have multiple cameras to, scan their environment and determine what's the next, best course of action for the vehicle to make. Right? That would be the example of an agent. And then there's other use cases where agents can be used, such as education, healthcare, cybersecurity, finances. You can just go on and on with this. So let's now talk about the different types of AI agents, right? Because there's quite a few here. So the first one we can talk about is simple reflex agents. And what simple reflex agents are is that they work based on current perceptions only, without taking past past states, right? So let's say an example of this would be a thermostat that will turn on and off based on the temperature. Most houses now have those kind of thermostats where if it gets to a certain temperature, it'll automatically turn off. Or when it gets to a certain temperature, it'll automatically turn on. This would be an example of a simple reflex agent. Now, there is a limitation to this, as it can't handle complex environments without, that require memory. Another type of agent would be a model-based reflex agent. So how this works is it maintains an internal model of the world to basically handle partially observable environments. So think back again to the self-driving car example I talked about before. A self-driving car will normally track nearby objects even when they move out of direct sight, right? Because obviously when you're driving, for instance, right, you want to keep track of almost everything that's around you, right? So this would be an example of where model-based reflex would be used. Now, the advantage is obviously it's way more adaptable than a simple reflex agent, right? Being able to, see different things and adjust adjust the job accordingly. So next up, you have the goal-based agents. And how this works is that it takes actions based on a goal rather than just reacting to the inputs, right? So think of it like this. Think of it like a chess game, an online chess game where you're playing against an AI, and the AI is evaluating moves every single turn, that that you take to achieve a checkmate. So this is just another example of an AI agent constantly adapting to a situation, right? And if you notice here, so far, since we started from the simple reflex agent, every single agent that we talked about so far has sort of been becoming more and more adaptable. Simple reflex was simply just, I can only really work in one sort of environment, whereas model-based reflexes sort of turn into more adaptable, and same with goal-based agents. So basically, each one has its own sort of set case, and basically sort of like doing its job better. So next up would be the utility-based agents, right? And how this works is that it will choose actions that maximize a utility function, or I guess I should say a measure of success, right? So an example of this would be, a recommendation system that will suggest products based on user satisfaction. So, an ad, all kind of ads that you get online are basically tailored to you based off of your search results, like how many, where do you go shopping, what do you look at, how long are you looking at things, right? All that algorithm, all that stuff, right, is used for utility-based agents. And the major advantage for utility-based agents is that it handles trade-offs and optimizes for best possible outcomes. And finally, we have the learning agents. And what learning agents do and how it works is that it improves the performance over time by learning from experiences. So an example of this would be reinforcement learning AI. I guess the only reinforcement learning AI that comes to mind right now is AlphaGo, right? AlphaGo is has been trained through reinforcement learning, just being constantly fed information like that. And I guess the benefit of doing this would mean that it will adapt dynamically to changing environments. And I am missing one more agent on the screen here, and that's multi-agent systems. Now, multi-agent systems are, how this works is that multiple agents interact and collaborate, or I guess compete with one another to achieve goals, right? So, an example of this I would say would probably be like, for example, stock market trading, right? You have all these different programs, all these different AI agents working together to try and produce the best results possible for these stockbrokers. And obviously, when you have multiple AI agents like this working, together or, against each other in competition, right? It can help you solve more complex problems through distributed intelligence. So as you can see here, each type serves different use cases, from simple automation to advanced decision making and learning, right? So AI agents, very, very interesting and very important for machine-based learning. All right, so next up, let's talk about Google's Vertex AI. This is something that I sort of researched on the side for this week's content. There's a lot of information here, but I'll try to go through it as quickly as possible. So Google's Vertex AI Agent Builder is a platform designed to facilitate the creation of many different AI agents that we previously talked about in the previous slide. And what makes this platform designer so unique is that it tries to use minimal coding, right? And that's one of the actual benefits that everyone talks about, right? Is that it takes no coding experience, no code development, right? And the reason why this is the case is that Google wanted to lower the barrier for entry to AI development, right? Because obviously, if you wanted to get into AI, you need to at least learn some kind of language. Normally, stuff like Python or C, stuff like those kind of languages, right? Which is very off-putting for some people. So by creating this, it makes it so that you can get more people into AI development without having to actually learn how to code. I guess another thing that's interesting about Vertex AI is that it has tool integration, right? The platform supports external tool integration, which means that the AI can call external APIs and execute Python scripts, for instance, right, and interact with business applications. So some example of the use cases, right? You have customer support agents, for instance, right, that integrate with systems such as Salesforce to retrieve user information. Or you can have AI coding assistants, which run snippets of Python to compute results dynamically. If you guys have ever been to the website Geeks for Geeks, right? A lot of the different web pages, when they talk about topics, will have basically a runnable Python code on most of those pages. That would be an example of this sort of AI coding assistant thing. And then I guess another example would be e-commerce bots, right? Pulling product details and stock availability from databases, right, to give customers an accurate representation of the item they're looking to buy, right? Another good example would be performance monitoring, right? Analytics, for example, right? You have the built-in dashboards will provide insights into agent performances, user interactions, and response accuracy. This will allow people to sort of track the conversation success rate, seeing how often the AI provides a correct response, and various other analytical benefits. So I did compile a bit of pros and cons to end off this section, right, as to like why I believe Vertex AI is good for people to try out, and then also some possible drawbacks as well. So some easy pros that I was able to spot throughout my research is that it's easy to use. Remember, little to no coding experience. There is strong data grounding for more reliable AI responses. You have a lot of seamless integration with, a lot of APIs and stuff like that. And then a high level of security standards, as well as it's scalable for large enterprises where they're still accessible to smaller teams. And then some of the potential drawbacks that I was able to find was that a lot of the features seem to be locked behind a Google Cloud pricing tier. So this isn't exactly something that you can just try for free at home. You're gonna have to spend a little bit of money here, but if you're interested in making AI and getting into the whole space, I think it might be worth the money. Anyways, that is everything for this week's weekly recap. I hope you guys all enjoyed the video, and I will catch you in the next one. Peace.